Hello everyone. The topic for today is box plots. Right now I want you to pause the video so you can copy down your notes and then resume when you're ready. A box plot is also known as a box and whisker plot, and it uses a number line to show distribution of a set of data using the median, the quartiles, that's first and third, and then extreme values. So let's create our box plot with the numbers that are given in this example. First thing we need to do is put them in order from least to greatest, because that's going to help us get things like the median and quartile 1 and quartile 3. So first number is 4, then 9, 12, 16, 17, 19, 20, and 22. Now that we have them in order from least to greatest, we can find the median. Well, we have 8 total numbers, so that means that our median is going to be somewhere in there. So we have to find the average or the mean of 16 and 17, which is 16.5. So our median is going to be 16.5. The lower extreme is the smallest number, and that's 4. So that's going to be the lower. Quartile 1, well, that is the median of every number to the left of the overall median. So quartile 1 is going to fall right in here in between 9 and 12. So again, we have to add 9 and 12 together and then divide that number by 2. So 9 plus 12 is 21. 21 divided by 2 gives us 10.5. So therefore, Q1 is 10.5. The upper extreme is the highest number in the data set, which in this case is 22. Quartile 3, again, that is the median for everything to the right of the overall median. So it's going to be somewhere in between 19 and 20, which is 19.5. Now, I just want to point this out. Notice how the median, quartile 1, and quartile 3, neither of those numbers is a number that's given to us in the data set. That is possible. That is it. A lot of people get confused because they think that you have to have a number that's listed in the data set. That's not the case. If you have a median or quartile 1 or quartile 3 that doesn't fall in the data set, that doesn't automatically make it wrong. So now we need to label our number line. So I'm going to skip count by 2s. So now we can label, or we can start placing the numbers here for our box plot. So starting with the upper and lower, the upper is 22, the lower is 4. We place a dot at those two numbers, the upper and the lower. It's just a dot. Okay. Then we place a line at the median. Well, that median is going to be somewhere in there. It's not always going to be exact, but it'll be somewhere about right there. Then we place another line at Q1, which is 10.5. That's going to be about right there. We're going to place a third line at Q3, which is 19.5, which is going to be about right there. Those 3 lines make up our box. So we're going to connect the box like so. After we connect the box, we're going to go from Q3 to the upper extreme, make a line, and we're going to make a line from the lower extreme to the edge of the box, which is at Q1. So that is our box plot. The only thing that we can determine if we were just given the box plot is those 5 numbers, the lower extreme, the upper extreme, Q1, Q3, and the median. Looking at another example, we're going to do problem number 1. First, we need to put the numbers in order from least to greatest to create our box plot. So let's put those in order. So those are our numbers in order from least to greatest. So we need to find 5 things. We need to find the median, Q1, Q3, the upper, and the lower. Well, I like to get the upper and the lower out of the way first. The upper is 16, the lower is 7. That way we know we have 2 of the 5 already without doing much math. The median for the data set, remember that's the number that's in the middle. So we have 10 numbers. So right down the middle, we've got those 2 numbers in the middle. Well, since they're both the same, they're both 10, that means that the median is 10, because 10 plus 10 is 20, divided by 2 gives us 10. Q1, that is the median on the left side. Well, that's the one in the middle. So Q1 is 9, and Q3 is 14, because that's the one in the middle on the right side. So we've got our 5 numbers. Now we've got to figure out which box plot matches those numbers. So we can eliminate choice B and choice D. We can eliminate choice B because the median is not in the right spot. That line right there would be the median. It's supposed to be at 10. So if that's not at 10, that can't be the right box plot. Well, the choice D can be eliminated because this line right here, well, that's at 12, and Q3, which is where that line should be, is 14. So looking at the remaining choices, the correct answer is C, because the upper and lower extremes for choice A are not correct. So I want you to answer question number 2. Bring that answer along with any questions that you may have with you to class tomorrow. And also, just as a small note, all of the information in a box plot is broken into sections of 25%. So looking at the example that we did before, this section is 25% of the data. The difference between the gap here, that is also 25% of the data. Yes, it is a very small portion or compared to the other one, but it's still 25% of the data. The gap from the edge here to here, another 25%. And then the final gap is another 25%. So regardless of how spread out or condensed the box is, each section represents 25% of the data.